Okay, Assalamualaikum and good afternoon. Okay, so let's start the class. Can you hear me?
Yes, madam.
Yes, madam.
Okay, so before that, this is about your quiz 4. So as I mentioned before, quiz 4 will be on Monday next week. Okay, so as usual, so we start at 4 p.m. So we finish about 4:50 lah. Okay. So the quiz 4 is about one-way ANOVA. Okay, only the one-way ANOVA. Okay, and for next week, there is no virtual class. Okay, since I will be on leave for a week. Okay, so there is no virtual class, so you have to study the subtopic for next week by your own lah. Okay, if anything, we can discuss on the next class. Okay. So next week only the quiz lah, okay, for the quiz 4. Okay, so today we will discuss the chapter 5. So we have finished the chapter 4. Okay, so chapter 5 is about linear regression and correlation. Okay, so regression, it is about relationship of the variables. Okay, it is about relationship of the variables. Okay. So we have about 6 subtopic for this chapter. Okay. So regression is about relationship of the variables. So means that you need to have at least 2 variables in order to apply this method. Okay. So 2 variables minimum. So one of the variables, it is a independent variable. Okay, and another one is a dependent variable. Okay, so dependent denoted by y and independent denoted by x. Okay, so simple linear regression means that we have 2 variables, okay, x and y. Okay, multiple linear regression means that we have more than 2 variables. Okay, but when you have the multiple linear regression, dependent still single. We still have single variable for the dependent, and you will have more than one independent variable. So it means that you will have x1, x2, and onward lah until xk. Okay, so that's multiple linear regression. Okay, so the model selection here means that you have a few models, so a mix of the simple linear model and also multiple linear model, and then we need to choose the best model, okay, based on some characteristic, and after that you use that best model for the prediction. Okay, so when you have the model or equation, okay, by using this you can predict some value lah given another values. Okay, so the whole chapter 5 here, okay, just for the introduction, okay, almost every numerical value that we calculate, we have to interpret. Okay, so chapter 5, it is about interpretation. How do you interpret the value? Okay, the value that you calculate. Okay, the what we call the calculation is quite simple for this chapter. Okay, the crucial part will be on how you interpret the value. Okay, how do you interpret the value? Okay, so for the simple linear regression, okay, almost all the value we can go to manual calculation. We go to the manual calculation, and also sometimes you are given output from Microsoft Excel. Then when you have the output, it should be able to read the output. Okay, the output for each value given, what does it mean? Okay, but for the multiple linear regression here, there is nothing that we have to calculate manually. Everything we just read from the output, so it is very crucial. Okay, in terms of how to interpret the output. Okay, you should be able to read the output when you are given the output. Okay, especially for the multiple linear here, because there is nothing that we have to calculate manually. Everything must be from the output. Okay. So for the both type of regression here, we still have the hypothesis testing involved here. Okay. So that hypothesis, it is about relationship between the variables. Okay, by using the sample data, we need to test whether they are related or not for the population. Okay. What else that you have to know? Okay, and the method that we use in this chapter, it is only for the quantitative variables. Okay, so your y and x here, they are quantitative variable. When you have the qualitative variable, okay, in future, let's say that you have qualitative variable and how to check how to discuss the relationship between that. Okay, you can use the logistic regression. Okay, so logistic regression. So which is will not be covered in this chapter lah. Okay, so this chapter only for the quantitative. So this is just for your information lah. Okay. So we go to the correlation first. 5.1 correlation. So correlation is a numerical value that we calculate to discuss the relationship between variables. Okay. Okay. So there are two type of numerical value that we calculate here to discuss the relationship between the variables. Okay, the first one is a correlation coefficient value, and second one is a coefficient of determination value. Okay, so for the chapter 5 here, it is important to know the notation, because when we calculate, you have to write the notation lah. And also it is important to know the terms that we use. Okay, correlation coefficient value, what is it? Okay, coefficient of determination value, what is it? Okay, because in your assessment, okay, quiz 5 letter, it is about the chapter 5, and also the final letter. Okay, in that question, we do not give you the notation. For example, calculate the R. No, okay, we use the terms. For example, find the correlation coefficient values and then interpret the value. Okay, so you have to know. Okay, correlation coefficient is what? Okay, coefficient of determination is what? Okay. So also in this subtopic, you have to plot the scatter diagram. We will discuss the scatter diagram. So scatter diagram is the first step that you can do to check the relationship between variables. Okay, it is like when we construct the normal probability plot. Okay, it is based on the simple step or the first step that we can do to check whether the data is a normal or not. So similar to here lah. Okay, scatter diagram, it is just a plotting between x and y. Okay, so based on that diagram, we will know whether there exists relationship or not between the variables. Okay, to confirm that, then we have to calculate the correlation coefficient and also coefficient of determination. Okay, you can interrupt me anytime if you have any questions. Okay, so independent variable, or we call it as a predictor, or we call it as a regressor. Okay, denoted by the X. Okay, notation that we use. Okay, dependent variable, or we call it as a response variable, denoted by Y. So means that Y depends on X. Okay, it will be some keyword in the question, okay, to notify which one depends on which one. Okay, and also it is based on our experience, the common sense, which variable depends on which variable. There is no rule to decide on the which one is a X, which one is a Y. Okay, it will be given some keyword in that question lah, so that we know which variable depends on which variable. Okay. So correlation here, okay, identify whether the relationship exists or not. Okay, and then quantify the strength of the relationship. Okay, so coefficient, correlation coefficient value. Okay, we can discuss whether exists the relationship or not based on that. Okay, and also the strength of the relationship lah. Okay, so linear regression express the relationship in the form of equation. Based on the correlation here, if exists relationship between the variables, then we can construct the equation to represent that variables. Okay, if not, then there is no use to form or to construct the equation. Whenever you have the equation, then we can use for prediction. Okay, prediction means that we estimate the value given another value. You can estimate the y given the value of x, or you can estimate the x given the value of y. Okay, either one. Okay. So for this example, the relationship between the number of hours students spend study for an examination and the mark they obtain. So means that the mark obtained here come after they study. So that's why number of hour here is a x and the mark they obtain is your y. Okay. Student will obtain a better final mark if they spend more time to study. So the comment that we write here, it just based on our observation on the data here. Okay. Why we can say this one? Because when y increase, when x increase, y also increase. So that's why we can say that student will obtain better final mark if they spend more time to study. So it just based on the observation. So to confirm that, then we have to calculate the numerical value. Okay. Okay, so first scatter diagram, just a simple plotting between the x and also the y here. But when you sketch the scatter diagram, there's no need to use the graph paper. Okay, just a simple plotting, but it must be with the proper axis. Okay, like what we do for the box plot. Okay, must be a proper axis. Okay, so the what we call the axis here depends on the data itself. Okay. Okay, so there is so scatter plot used to plot the pairs of data to investigate the relationship between two variables. Okay. So this is the first step in order to check whether there exists relationship or not between variables. Okay, so there is a four common trend that you can write. The first one, positive linear. So positive mean x increase, y also increase. And then you can have the negative linear trend. X increase but y decrease. And then you can have the curvilinear ups and down. When x increase, y will be ups and down here, then you will have curvilinear. Okay. And sometimes there is no trend, means that your data scattered to each other. Okay, so this is a four common trend that you can write. Okay. Okay, this is just the it just based on the visualization. Okay, whether there exists relationship or not. Okay, so to confirm that, we calculate the correlation coefficient. Okay. So correlation coefficient, also known as a percent product moment correlation, another terms that we use, denoted by capital R or rho for population correlation. If the data given is a population data, then it is a capital R and rho. Okay. But if you have the data, means that sample data, then it is a small r. Most of the time we have the sample data. Okay. So used to indicate the linear degree of the scatter plot. Okay, the arc that we calculate here must be consistent to the scatter diagram that you plot. Okay, if you have positive, then it must be positive. So that's why a linear degree here. Okay, based on arc, then we can say that it is a positive or negative. Okay, to confirm the scatter plot. Okay, so R and scatter plot must be consistent to each other. They cannot be contradict to each other. Okay. So the value of R measure the strength and direction. Okay, direction means whether you have positive or whether you have negative. So depends. If the R that you calculate positive, then you will have positive direction. If the value of R here, you get negative, then it is a negative direction. Okay, the strength means that level of how much they related to each other lah. Okay, so we have weak, we have the moderate, and then we have the strong. So how, which one is that, which one, whether the R value that we calculate weak, moderate or strong, it is based on this table lah. Okay, this table. Okay, so the R, it is between -1 to the 1. Okay, so regardless the sign here, if R equal to 1, it is a perfect correlated. If R from 0.7 to the 1, it is a strong correlated. If the R between 0 to the 0.5, it is a weak correlated. When R equal to 0, there is no correlation at all. Okay, this is what I said. If R equal to 0, so there is no use to form the equation. So, so if R equal to 0, the next step is to discard the variable that you have and then collect, or collect the data on the another variable lah, because if R equal to 0, there is no use for us to use that variable. Okay, it will give the result that you get might be invalid later lah. Okay, okay. So that's how we know the strength of the relationship. Okay, by using scatter plot, we cannot know the strength of the relationship, but we can get a good sense of the strength of the relationship. Okay, if your data point here, it is close, the line that we have here, we call it as a regression line. Okay, so if your data point close to the regression line, means that you will have a strong relationship lah. Okay, if your data point here far from the regression line, so you have the weak relationship. Okay, why? Because when the data point here close to the regression line, your R will be close to the 1. Okay, so R close to the 1 means that you have strong relationship lah. So it will be quite impossible to get R equal to 1. Okay. So your R dimensionless, there is no unique, and your R is not robust since it is easily affected by the outlier. Therefore, we should always check the scatter plot with the R value. Okay, when you plot the scatter plot, if you have the outlier, it will be illustrated in your scatter plot, because we know we know that the scatter plot is isolate from the rest of the data. So if the outlier exists, then it will be shown in your scatter plot. Okay, so why is a R easily affected by the outlier? Anyone? Why it is easily affected by the outlier? You can relate with the chapter 1. It is similar reason as why mean or average affected by the outlier. Why it is affected? Easily affected by the outlier? Anyone? Data value will change significantly. No. How to change when we have the outlier? No, the data value will not be changed. Okay, it is affected because the formula itself. Okay, because when we calculate the R here, R is about the SXY, SXS, SYY. Okay, to calculate these three measures, we use the sum of the value. we have the sum of x, we have sum of y. So if outlier exists, it will be influence the sum of value here. Okay, it will be influenced. So that's why R here easily affected by the outlier because the formula is solved. Okay, it is about summation of value. Okay, that's how the outlier affected the R. Okay, so the calculation here is quite simple one. Okay, you can use your calculator to get all the summation value. Okay, all the summation value. No need to calculate manually to get this summation value. Okay, use your calculator and then obtain the summation value, but you have to key in the data lah. Okay, so how to key in? Okay, you can refer to this start. Okay, the start in this slide. Okay, so this is how we key in the data lah. Okay, you just follow the step here. Okay, so then you can get all the summation value, no need to calculate manually. Okay, so example, after this I will share to you the video how to use the calculator. Okay, okay, example 5.2. Okay, so do not follow this one, don't calculate manually this summation. Okay, you can get directly from calculator. Okay, so the calculation I leave it to you. Okay, when we discuss the exercise, we will discuss how to interpret the art here. Okay, the most important one is a direction and also the strength must be there lah in your interpretation. Okay, based on the value here, what is your direction and what is your strength. Okay, both must be mentioned in your interpretation. If not, you will lose your mark. Okay. Okay, coefficient of determination. So coefficient of determination come from the R because when you have the R, you just square the value, then you will get R square. So notation for the coefficient of determination is R square lah. If it is a sample data, if it is a population, then capital R square. Okay. So coefficient of the determination, it is about proportion of variance. Okay, independent variable that can be explained by independent variable. So it is about percentage or proportion. Proportion, then from proportion we convert into percentage. Okay, so it is about percentage of the variation independent variable that can be explained by independent variable. Okay. So we will discuss in the exercise after this. Okay. So some of the researcher, they will go to the R square lah because it is about the variability, so it will be more significant to discuss. Okay. So R square, it is between 0 to the 1 only. Okay. For the simple linear regression. When we go to the multiple linear regression, sometimes coefficient of determination could be in negative value. So what does it mean when we have negative value? Okay, that one when we go to the multiple lah. Okay. Okay, so 5.2 simple linear regression model. So by the end of this topic, you should be able to write a mathematical equation that relate dependent and independent variables. Okay, draw the linear regression line, okay, on your scatter plot actually, on scatter plot. Okay, interpret the value of intercept and slope and use the equation of the regression line to estimate the value. This is what I said prediction. Okay. Let's now here. Okay, so this is a general model for the simple linear regression. It is similar as what we discussed in secondary school ymx plus c. Okay, similar idea lah. Okay. So beta node here, it is your intercept. Beta 1 here, that's your slope. And epsilon, the random error. Okay. To discard the epsilon, then we will use a fitted model. Okay. So we use a least square method to used to estimate the parameters. Okay. So for the simple linear regression, we have two parameters, which is intercept and also slope, beta 1 cap. So when we say estimate parameters, so this is what we meant. Okay. We have to find the beta node cap and also beta 1 cap. Okay. Okay. So when we use a fitted model, there is no epsilon. Okay. So intercept here also called as a regression constant, and slope here also called as a regression coefficient. Okay, some question it will be like interpret the regression coefficient. So you have to know it is about beta 1 or beta node. Okay. Okay. So slope, okay, if we need to interpret the slope, it is about the amount of increase or decrease of y for each unit increase or decrease in x. Okay, that's why we go up during for the exercise lah. Okay. So this is how we calculate. Okay, just a simple calculation. Okay, this one I leave it to you. Okay, properties. Okay, so the equation here or model, similar thing. Okay, we use to estimate a value of variable given a value of another. Okay, so means that, so this is your model. When we have the value of beta node and beta 1, so you will have a complete model lah. Okay, you can interpret, you can predict the y given the x, or you can predict the x given the y. Okay, so there is a two method for the prediction here. The first one, interpolation. So interpolation means that we predict value within the range. Okay, we predict the value by using the given value within the range of data. So that's interpolation. Extrapolation means that we predict value which is outside from the data. Okay, so when you use the extrapolation, you might get invalid result. Sometimes you will get negative value, or you will get the value which is outside from the limit of that variable. Okay, so we have to be careful with the extrapolation. Okay. Okay. So guideline for using simple linear regression equation. This is for condition. Okay, so this is for condition of where we cannot use simple linear regression equation, or we cannot use the multiple linear regression similar. Okay, so this is for condition of where we cannot use the regression equation. The first one, if there is no linear correlation, so means that when r equal to 0, so no correlation, so do not use the regression equation to make a prediction. Okay, when r equal to 0, there is no use for us to form a equation. Okay, if it is your own research, what you can do, discard that variable and replace with the another variable lah. Okay, so when using the regression equation for the prediction, stay within the scope of the available sample data. Be careful with the extrapolation method, the one that I just said just now. Okay, we have to be careful with the extrapolation. Sometimes the result that you get will be invalid lah. Okay, A regression equation based on the old data is not necessarily suitable for the current data. Okay, let's say that we need to predict something current. Okay, so we cannot use the equation from like 10 years old data. Okay, you have to use a current model by using current data. So the fourth one, do not make prediction about a population that is different from the population from which the sample data were drawn. So means that if your equation here from population A, okay, okay, so we have equation from the population A, so we cannot use the equation from A to predict by using the data from B. Okay, it is not valid lah. Okay, if you need to predict by using the data from B, then you have to construct their its own equation. Okay, questions so far before we go to the exercise?
No, madam.
No. Okay. Okay. Okay, so this exercise, a study is conducted to investigate the relationship between the cause of fire damage and the distance between the fire station and the location involved in the fire accident using regression method. Okay, the data is given as follows. So we have cause of fire damage and also the distance between fire accident to the fire station. Which one is your X and which one is your Y? Your X?
Distance.
Distance. So the Y is a cos. Okay, cos is not the X. Okay, distance is your X because cause of fire damage depends on the distance of the fire accident to the fire location. Okay, so if far, then it will be takes time lah to get there. Okay, that's why the cost might be increased lah. Okay, might be higher. Okay, so this is what I said. There is no specific rule to decide on the X and Y. It has to be depends on the question and also depends on the common sense. I use common sense. It is a common sense to decide which one is a X, which one is your Y. Okay, so cost is your Y, and distance is your X. Okay. Draw a scatter diagram and give comment. As I say, use a proper axis to draw your scatter diagram. Okay, it just you plot a pair, okay, pair of the data here, okay, and give comment. What you get for your scatter plot, the trend?
Positive.
Positive linear trend. Okay. C, no need to calculate manually. Use your calculator to get the summation value. D, calculate the correction coefficient and interpret its value. Okay, in the assessment, okay, final or quiz letter, usually we not mention it is a R. So you have to know by your own. Okay, correction coefficient is R. Okay, so similar coefficient of determination, we do not state here it is a R square. Okay, it is a R square. You have to know by your own. Okay, coefficient of determination is a R square. Okay, we go to the D. Okay, so what you got for your R?
0.9541.
Forward. Okay. And then interpret. Okay, for the interpretation, okay, you have to know what is your direction and you have to know what is the strength. So what is the direction here?
Positive.
Positive.
Positive. Strength?
Strong. Positive
Strong.
correlation.
Strong because 0.9, it is between 0.7 to the 1. Okay, so we know it is a positive and also the strong. So in your interpretation, you need to have these two items lah. So there is a strong positive linear relationship between, you can mention X first and Y, or you can mention Y first and X, between cause of fire damage and the distance of fire accident to fire station. Okay. E, coefficient of determination, you just square the out that you get. What do you get?
0.9102.
9102.
02.
Okay. 02, 03 also accepted. Okay. And then interpret. So coefficient of determination, it is about percentage of variation. So we have to convert into percentage when we interpret. 91.02% of variation in Y. So Y is a cause of fire damage can be predicted or explained. Similar thing. Predicted by your X distance of fire accident to fire station. Okay. So variation is very important. Tak ada variation, tak ada markah lah. Okay. Because that's what coefficient of determination mean. Okay. So in general, this is your Y. Okay. Can be predicted by X. This is your X. Okay. And then estimate the regression parameters and write the estimated linear regression model. So we need beta node cap and also beta 1 cap. So beta node apa?
9.3983.
9.3983.
83.
Okay, beta 1.
5.1817.
1817. Okay, and then just write the model. So Y cap beta node 93983 plus because of positive 7 X. Okay, nak tulis yang ni dulu pun boleh, yang ni kemudian pun boleh, tak ada masalah, as long as x here with slope, not with the intercept. Okay, it's up to you. Okay, the next question. Give interpretation of regression constant, your beta node cap, and regression coefficient, your beta 1 cap. Okay. Apa tadi? FG. Okay. So beta node first. 9.9. Okay, so in order to interpret beta node cap, we let x equal to 0. Okay. So when your when the distance of fire accident to fire station is 0 or help constant, sama je dalam buku. Sometimes we use help constant sama. Then the estimated your y, so y is a cause of fire damage, then the estimated cause of fire damage is, then you state the beta node with the unit of y. Is there any unit for the y? Ada unit for the y?
RM.
RM. Sorry. So is RM 93983 million, isn't it? It is a RM million. Okay. So in general, this is your x. Okay. Then the estimate, this is your y, is in general beta node cap with the unit of y. So kalau ada unit, state the unit. Kalau tak ada unit, without the unit. You just state without the unit. If tak ada unit, so is 9.3983. That's it. Okay. If unit exists, then you have to state the unit lah. Okay. So beta 1 cap 5.1817. Okay. Okay, so slope, it is about how much y change when x change. Okay, so that's what you need to write lah. Okay. The estimated your y cause of fire damage is increase because of positive. If negative, then decrease. Is increased by beta 1 value with the unit of y. RM 51817 million for every exchange. Okay, for every, ada unit for the x?
Kilometer.
Kilometer. For every km of location, your x. Sorry, for every km of the distance between fire accident to fire station. Okay, so in general, so kalau negatif kat sini, so sini akan jadi decrease. Di sini akan jadi decrease. Okay, so decrease means that we have negative slope. Okay, so kalau negatif tak perlu mention negatif kat sini, tak perlu. Okay, tak perlu dah mention negatif. Okay, decrease means that we have negative slope. So in general estimated, this is your y. Increase or decrease depends on beta 1 value by this is, I put here, beta 1 cap with unit of y in general. Okay, for every, sini mesti unit of y if exists. Kalau tak ada unit, you just mention for every of x. Okay, this is your x. Any questions so far? Okay. Next question, predict the cost when the distance is 10. Predict the distance when the cost is 10 million. That one 10 km. Okay, so the H question here, you have to know. Predict the cost. So what is your cost? X or Y? Then kita tahulah kita nak substitute dekat value mana. Okay, when distance is a 10 km. So we know that cost is a Y. So here we need to predict Y given the X. Okay. GH. So just now we have this model. Okay, so we need to predict the cost, which is the Y. So means that we substitute the X here with the 10. Then you will get, don't forget the unit, which is RM, the value, and then million. Okay, tak ada unit, salah lah. Okay, and then GHI. The next one, predict the distance. So we know that distance is X when the cost is a 10 million. So this is your Y. Okay, similar equation, but now we have to substitute Y with the 10 and then we are looking for X. So, okay. Y is a 10. Okay, so algebra sikit. So X equal to 10 minus 9. Okay, so since we predict the X automatically, X ni akan jadi X cap lah. Because Y cap ni means that prediction. So because we predict the X, then X ni with the cap. Okay, so you akan dapat nilai dia, don't forget the unit which is km. Any question?
No.
No, Okay. Okay. So that's all for this week. Okay, then you continue for the next week lah, the next subtopic. Okay. So as I mentioned earlier, there is no visual class next week. Okay. So only quiz 4 lah next week, which is on Monday as usual at 4 p.m. Okay. It is about 1 way ANOVA. Okay. So I think that's all for today. Happy holiday, Merry Christmas and Happy New Year. Okay, I see you after the New Year lah. Okay. Thank you class. See you next time insyaAllah.
Okay, thank you, madam.
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 Okay.
Thank you, madam.
Okay.
Thank you, madam.
Okay.